Welcome to our website of Business Analytics. We worked hard to collect, analyze, and predict data to make decision making easier. The basis of our data analysis is conducted through business analytics. Business analytics is the use of data, information technology, statistical analysis, quantitative methods, and mathematical or computer-based models that help managers improve their business operations. Examples of practical applications include analyzing data found through social media, which can allow you to identify trends in customer perceptions. With the increasing popularity of big data, companies are looking for data scientists to create a story with their insights. The three main types of business analytics are descriptive, predictive, and prescriptive analytics. Descriptive analytics encompasses the set of techniques that describes what has happened in the past. Predictive analytics consists of techniques that use models constructed from past data to predict the probability of the future or the impact of one variable on another. Prescriptive analytics is applied to identify the best outcome for events given the parameters and suggest decisions that take advantage of future opportunities or mitigate a future risk. Now we shall introduce a key subject that pertains to business analytics that we have studied: data visualization. Data visualization involves creating summaries for data through tables, charts, and graphs. It also involves creating a dashboard to display the results of the analyzed data. Dashboards can provide you with visual representation of your complied data. You can get a quick visual status update on your projects and even examine data into important details. Dashboards can boost your organization's speed, which allows you to see, manage, and communicate more. Dashboards' visual nature has the ability to simplify complex data and provides quick view of the current status by providing real-time performance updates. In the example we did in class, we extracted data from the Chicago Police website and used SQL to help clean up the data and provide us with insights. We then transferred the data to Tableau to create a visualization and a storyboard to showcase our findings concerning the elevated crime issue. The storyboards allowed us to pinpoint where, when, and what types of crimes are happening in visual form for people to understand without having an analytic background. Now we will introduce a key subject that pertains to a business analytics that we have studied.
The first is multiple linear regression. Multiple linear regression attempts to model the relationship between two or more explanatory variables and a response variable by fitting a linear equation to observed data. Every value of the independent variable x is associated with a value of the dependent variable y. In a project we completed early in the semester, we were asked to determine what factors have an effect on college and university graduation rates. Using an Excel spreadsheet, we were able to predict the graduation rate of the colleges and universities based on the school's SAT scores, acceptance rates, student expenditures, and percent of students in the top 10% of their high school class. The second is Monte Carlo risk simulation. Monte Carlo is one of the more advanced analytical tools used by professionals today. This technique is helpful for modeling situations in which uncertainty is a key factor. It can describe not only what the outcomes of a given decision could be, but also the probabilities in which these outcomes will occur. The result of a simulation is the entire probability distribution of outcomes. It provides two essential pieces of information: mean values and tail probabilities. The mean values are the expected output, and the tail probabilities is usually the probability of a positive output. In the histogram displayed, we see a normal distribution. Values in the middle of the chart near the mean are the values that are most likely to occur. The output is symmetric and describes many natural phenomena such as the company's time frame for fixed expenses and net present value. The third is decision trees. Decision trees create segmentations of the inputted data based on a series of rules. The goal of decision trees is to find one main variable that splits the inputted data into separate groups. Decision trees can be created using business visualization tools like SAS Visual Analytics. This software will also output a leaf statistic and an assessment which can be used to better understand the data.
The fourth is time series analysis and forecasting. Time series is a sequence of observations of a variable that is measured at numerous points in time. For example, measuring something over a stream of historical data, such as weekly or monthly sales. The purpose of time series is to analyze the data to uncover some kind of pattern, the use of that pattern to predict the future, in essence, forecasting. Usually, when looking at the data, the first step is creating a plot to visualize the relationship between time and the variable you are looking at. When looking at the chart, you can discover several observations like whether a pattern has a trend, is it seasonal, cyclical, or a combination. The fifth is data mining, cluster analysis. When doing cluster analysis, you can use programs such as SAS Analytics to better understand characteristics of large data that contain numerous variables. The program sections data in clusters, taking into consideration some of the most common variables. Through this type of assortment, a data scientist can uncover patterns that would otherwise gone unnoticed. The benefits of cluster analysis is that the program automatically puts variables together that seem relatively similar.
Next, we will discuss optimization, which can be utilized in Excel. Optimization is the process of selecting values of decision variables that either minimize costs or maximize profits. Linear programming is the most widely used optimization technique in practice. Models generate insight which lead to better business decisions. The use of models allows us to break problems down into components and come up with a ballpark estimate. Not only do models reduce costs, but they allow us to make inexpensive errors. In this problem, we know our costs, revenues, and time constraints, and want to know how many projects we should complete to maximize profits. Mapping out a business problem by setting parameters, identifying constraints, and defining the decision variables and objective make it as easy as the click of a button to decide how many projects we should choose to maximize profits. Last, we will cover data mining, k-means clustering using XLMiner in Excel. Data mining is used to identify relationships among variables in large data sets and understand hidden patterns. K-means clustering is a data mining technique that uses unsupervised learning or machine learning that uses algorithms to make inferences from data sets without labels. K-means clustering can be used to confirm business assumptions about the types of groups that exist or identify unknown groups in a complex data set. Once the algorithm has ran and groups are defined, any new data can be easily assigned to the correct group. Here we have a data set of credit union members in which we want to determine if they are at high or low risk of receiving a loan. We will use XLMiner to find the best K or number of clusters in the data. First, we partition the data into training, validation, and testing. It is important to give a heavier weight in training so the program can make accurate classifications. We are using variables collected by the credit union as our input variables and credit risk as our output, since we want to know which of our customers are at high and low risk of receiving a loan. We use two classes. Success is represented by the number 1 and fail represented by the number 0. Here, we can also change our rounding cutoff for success. Depending on the industry you are working in, this number could go higher or lower. In this step, we can elect to use a specified value of clusters if we already know what that is, or we can give it a maximum number and let the model tell us our best K. We will use 20 and see how many XLMiner chooses. The model has determined that the credit union members are broken up into 18 different clusters. Here we can see how many observations were misclassified and our overall error report. For this data set, 28 out of 84 observations were misclassified, with an overall error rate of 33.33%. We can take them as classified data, highlighted in blue, and characterize it to see any similarities amongst the observations. Next, we can look at the lift chart to see the advantage of using the model. The decile-wise lift chart breaks down the observations into tenths and the ROC curve. In an ideal model, the ROC curve will push upward and to the left, giving us the most advantage. This particular model is not great, but we can observe that it's better than random guess. Now that we have trained the data, we can use k-means clustering to determine if new customers are at high or low risk of receiving a loan. The ones in the predicted class are credit union members that the model has found to be a success or at a low risk. Excel Miner also allows us to use a logistic regression model. We can continue to run the model and remove insignificant variables one at a time until our model includes only statistically significant variables. We can then compare the models by looking at the lift charts and ROC curves to determine which one gives us the better advantage and use the model to make data-driven decisions. Thank you for listening. We hope you enjoyed our presentation.